So some reactions can happen in a split second, and some chemical reactions can take years and years to proceed. But the rate of all chemical reactions can be changed if the environment or the conditions that they're in changes. So there are 5 ways that the rate of a chemical reaction can be changed. So the first thing is, if we have increased the concentration of the reactants in a chemical reaction, so if we used to have just a few chemicals and they're all bouncing into each other and reacting together to form new chemical compounds, then that reaction would occur, but it would be somewhat slow because it would take a while for all the chemicals to bump into each other. But if we increase the concentration of the reactants, then they'll bump into each other far more quickly. So they're bumping into each other all over the place here. And so therefore the reaction is happening way faster when you've got more of the reactants. So more of the things together in a smaller area basically makes the reaction go faster. Another way to increase the rate of reaction is to increase the pressure of a reacting gas in particular. So again over here, if I've got some molecules that are waiting to react together and they've got quite a lot of space between them, then they're not going to bump into each other and react as quickly as if I put a lot of pressure on them and squish them into a smaller space so that they bump into each other more often, and then they're more likely to react more quickly. So again, increasing the pressure will increase the rate of reaction. Another way to increase the rate of reaction is to break a solid into smaller pieces. So here I've got, in fact, it's a piece of magnesium. So this is a piece of magnesium here, and it's reacting with some hydrogen, is the red bit. So periodically the hydrogen will bump into the magnesium and form a brand new product here. So we've got magnesium plus hydrogens forming this brand new product, MgH2, so 2 hydrogens with each magnesium. But if I break the magnesium into smaller pieces, you'll find that there's so much more area for the hydrogen to bump into. So if I've increased the surface area, in fact, of one of the reactants, I'm basically enabling the 2 chemicals to come into contact more often, and the more often they do that, the rate of reaction occurs faster. So if I break a big solid into smaller pieces or increase the surface area of one of the reactants, then again the rate of reaction will increase or go faster. Yet another way to increase the rate of reaction is to increase the temperature of the 2 reactants. So if I increase the temperature, the molecules will move around faster and they'll bump into each other faster and harder. And when that happens, they're more likely to join together or break apart. So the reaction is more likely to happen if the temperature is increased. And the last one here is if I use a catalyst. A catalyst is basically another chemical which can make chemical reactions go faster, but it is not itself used up in the reaction at all. So a chemical may kind of make a little fall into a hole in a catalyst, and then it will break into 2, and the catalyst will not be used up, but it will make the chemical reaction go faster. So catalyst is really just something which makes chemical reactions go faster, but it's not used up in the actual reaction it's influencing. So there's a few different ways to increase the rate of a chemical reaction. We can obviously increase the concentration of the reactants, put more pressure on the gas to make them fit in a smaller space, break solids into smaller pieces to increase their surface area, increase the temperature, or use a catalyst. They're all ways to increase the rate of a chemical reaction.